It says here, Samit has a pond in the shape of a prism. Now, first thing which I'm going to do here is there's a mathematical word used here, prism. So I need to think about what a prism is. A prism is a 3D shape which has a constant cross section, i.e. the cross section is the area that runs all the way through the shape. It maintains the same size and same shape. So I can see that the prism has this as the cross section area, as I've just kind of highlighted here. This is the cross section because it goes all the way from the front to the back and it still stays the same. So that's the first thing that I've written down, okay, or kind of understood. Okay, I'll tick that. I understand that. I understand what a prism is, and that's how you should be thinking. Do not just read, comprehend each sentence, do the maths if possible, and then move on. Okay, so in the next sentence, it goes on to say the pond is completely full of water. Now, the word full implies that we are going to be working with volume. If it said the prism is covered with paint, that would imply surface area. So it's really important to understand some of these words used. So full means we're referring to volume. So at this stage, I'm going to stop and I'm going to actually work out the volume for this prism. I know I haven't read anything else, but I'm going to do line by line maths. Remember, I'm going to stay true to what I'm teaching, which is approach this line by line. So how do we work out the volume? Well, volume, I'm going to write down my formula. Volume is equal to cross-section area times the length or the depth. So my cross-section area is this shaded shape that I've shown you here. And to work out this cross-section area, let's focus on the cross-section area first. The cross-section area is a trapezium, so I'll write down trapezium, and I'll then remind myself how I find the trapezium area. Trapezium area is half of A plus B times height, where A and B are the two parallel sides. So where are my two parallel sides? Here's A, and B would be this bit here, which is 0.5, as I can see it's on the back as well. So that's my B. So they're my two parallel sides. And the height would be the distance between them here. So it's this bit here, 2 meters. That's the H. So if I go and put that in and find out my cross-section area for the trapezium first. So that's half of 1.3 add 0.5 times by 2. So what I've got here is 1.3 add 0.5, which is 1.8. Half of 1.8 is 0.9, and then times by 2, which gets you back to 1.8. And the units there are meters, so meters squared, because I've worked out an area. I'll go back to my volume. The volume is equal to the cross-section area, which is 1.8, times the length. There's the length here. Can you see there, that bit there, 1 meter? And so I'm going to times it by 1. And that gets me 1.8 meters cubed. Now I've worked out the volume, all just from that second sentence. Okay. Right, so what next then? Well, then it goes on to say Samit wants to empty the pond so he can clean it. Okay, I've understood that he needs to empty the pond. It's full of water, so we need to try and get rid of that whole 1.8 meter cubed. Samit uses a pump to empty the pond. Understood. It then goes on to say the volume of the water in the pond decreases at a constant rate. Now, this is important to understand. So what this essentially is saying, whenever you have volume decreasing at a constant rate, rate is always to do with, the word rate is associated with time. So we can actually write this in a particular way. What we need to do is we need to form a multiplicative reasoning kind of starting point here, where we need to write down something like this. How much volume has... Well, it's, remember, volume of the water decreases. So how much volume decreases after a given time? So we need to be able to set it up like this. How much volume empties and how long it takes. Now it tells us in the next sentence what that is. It tells us that the pond goes down by 20 centimeters in the first 30 minutes. Now, a common mistake I'll show you here. So don't copy what I'm going to do here. This is a common mistake made. So often students write this down. They write down 20 centimeters equals to 30 minutes, which might seem correct at first glance because you've got two measures and you're writing multiplicative reasoning, but not quite, because it's talking about the volume of water decreasing at a constant rate. We need to find the volume emptied in 30 minutes, not how much height has reduced in 30 minutes, but how much volume has emptied? So with these volume questions, always, if they give you something like this, height, work out, instead of that 20 centimeter, work out what the volume is for this 20 centimeter. Okay, volume for 20 centimeter. Okay, that's what we need to work out. So let's go and work that out first. So it says here the level of the water pond goes down by 20 centimeters in the first 30 minutes. So I'm going to focus on this here, 20 centimeters. So if it goes down by 20 centimeters, 20 centimeters is 0.2. So it would, this is how much water would have emptied in that first 30 minutes. So we need to essentially work out this volume of water. And then we can say this volume is equal to 30 minutes using this. So let's go and work out first of all what that volume is. Okay, so I'm going to work out the volume for that rectangle here. Volume for 20 centimeters is, well, what's the volume? Volume is, this is a cuboid, as we can see here, the blue one that we've got highlighted, and it's 2 times 0.2 is my cross section, and then times by 1. So I can go and work out that volume straight away. So that gets me 0.4 meters cubed. That's how much volume has emptied in that first 30 minutes. And now I can go and set up the correct multiplicative reasoning. This, remember, was not correct. Okay, so what is the correct multiplicative reasoning starting point? Well, volume emptied is 0.4 meters cubed. And how long did it take? It took us 30 minutes. Okay, so that's from this line here. Now we're at a good point. We can actually go and do other things to this. So I've ticked this line off, ticked that off. I've done the maths for that. And we want to work out how much more time Samit has to wait for the pump to empty the pond completely. Not how much time in total, but how much more time. Now he's already emptied 0.4 meters cubed. Remember what the total volume was. It was 1.8 meters cubed. So how much left to empty? We've got 1.8, take away the 0.4 that's emptied. So that's 1.4 meters cubed. So we've got to empty another 1.4 meters cubed. So I'm going to write down 1.4 meters cubed. That's how much more we have to empty. So I'm going to then figure out, how do I go from 0.4 to 1.4? Okay, so I need to figure that out. So 0.4 to 1.4 is times by 3.5, and you can figure that out using your calculator. Or 0.4, if you go up, it goes to 1.2, and then there's another half, lots of that. So I need to do the same on that side, times that by 3.5 also. So 30 times 3 is 90, times 3.5, another, it will give us 105 minutes when we times it by 3.5. So this is how much more that has to empty, and this is how much more time that's needed to empty that. The question is asking, work out how much more time Samit has to wait for the pump to empty the pond completely. So the answer we would write down is 105 minutes. Okay, so that's our final answer. So what are the skills that we used here? Line by line maths. When you see a keyword, make sure you try and write down any equations associated with it. So prism, volume, cross-section area times length. That's writing down equations that we can recall. And then as we approach line by line, we then use multiplicative reasoning where we could. Okay, right, so your turn to have a go. I'll leave this one up, but the question that I'd like you to have a go is the question 2 mirror question now, please. Water trout is a prism, and it then goes on to say Hamish fills the trout completely. So at this stage, I'm going to work out the volume, because the word fill means to refer to the volume. So the volume is worked out by doing cross-section area of this prism times the length. Now this cross-section area, as we can see here, is actually not quite a regular shape that we know. It's not either a rectangle or a trapezium. So what I'm going to do is I'm going to split it up to form a rectangle. So there's my rectangle, and there's the prism. So I'm going to work out the number them. I'll work out number one's volume first. The rectangle is worked out by doing, I'll write down here, number one, volume is equal to 20 times 120 and then times the 30, volume of a cuboid, and that gets us 12 times 2, which is 12 times 2, which is 24, and then 24 times 3, which is 0.000 centimeters cubed. For shape 2, the volume is it's a trapezium, so the trapezium is worked out by doing, first of all, the trapezium area is half A plus B times height, but then we're timesing it by the length because I've got here volume written. Okay, so what's that? Well, it's half of the two parallel sides, which are 80 and 120, times by the distance between them, which is 40, and then times by the depth or the length, which is 30, to work out the volume. Okay, so let's go and tidy this up here. So 120 add 80 is 200. Half of 200 is 100. So then we've got 100 times 40. So 100 times 40 is 4,000 times by the 30. 4 times 3 is 12, and add the 4 zeros, 1, 2, 3, 4. So that's what we have for the volume of that. So the total volume is equal to this 120,000 plus the 72,000 that we had, and that gets us our total volume, which is 192,000 centimeters cubed. That's all from this first line. Hamish fills the trough completely. By doing things like that, you are actually picking up method marks. So don't overlook this, and make sure you always show you're working. Water leaks from the bottom of the trough at a constant rate, and 2 hours later the water level has fallen by 20 centimeters. So constant rate means we need to set up something. When something leaks, volume leaks, we need to set up volume, how much has emptied in a given time. Now on that third line, they mentioned 2 hours is how long it takes to drop by 20 centimeters. But remember that 20 centimeters is not a volume. We need to work out volume for 20 centimeters, for the first 20 centimeters. So how much empties in that? Well, can you see that 20 centimeters that it drops is this much? This is how much has dropped in the first 2 hours. So that's the 20 centimeter drop. And I've already worked out that volume for number 1. Remember, it's here, my volume, oh, sorry, wrong one. That's not it, it's this one here, 72,000. So I can set up multiplicative reasoning. How much volume has emptied in that 20 centimeters? This one, 72,000 has emptied in how long? 2 hours. That's all from that third line. So I can tick those lines off. I've done the maths for that. Water continues to leak from the trough at the same rate. How many more minutes? Again, the word more meaning we need to find out how much more volume to empty. We've got how much more volume to empty. Remember, we've emptied 72,000. So how much more is left is this one here, 120,000. So we need to get to 120,000. This is how much more left to empty. How do I go from 72,000 to 120,000? Well, there might not be a direct route to there. I mean, if it's non-calculator, I'll just write this out here underneath. Leave a bit of space here. What I'm going to do is I'm going to try and figure out, is there a number that goes into both 72 and 120? The number that goes into both of them is 6. 6 goes into both of them. So I'm going to work out what it is for 6,000. Now, to get to 6,000 from 72,000, that's the case of dividing by 12. So if I divided both of them by 12. Now, notice here I've got 2 hours. So instead of working in hours, I might just write that down in minutes. I'll write down in 120 minutes. Because with hours, if I divide by 12, I'll get a decimal. So it's okay to do things like that, where you write hours in minutes and convert back if you need to. So dividing by 12, 120 divided by 12, well, that's 10. So we can see here that it takes 10 minutes to get 6,000 centimeter cubed. I should put my units here. And I want to get to 120,000 centimeter cubed. So to go from 6 to 120, that's times by 20. So times by 20, so I'm going to do the same thing on the other side, times by 20. And if I times that by 20, it takes me 200 minutes. So this is how much more minutes. What did the question say? How many more minutes? So I need to make sure I leave my answer in minutes. So it should be 200 minutes. Okay. Right. So moving on. This one's a very